Hello everyone, I'm Gergely Sipos. If the last talk waked you up, I make sure I put you back in sleep because I will show you some code. So I'm a front-end developer, architect, enthusiast at Doctorsoft. You met my colleagues earlier. Tamás talked about Spanner and Csaba about big data. I'm going to talk about Angular and RxJS and how you can work together with these two libraries, frameworks. You could, just a quick question, how many of you have done at least a Hello World app with Angular 2? Okay, there are some. And how many would you say that you know RxJS well or RxJava? A lot fewer. That's because actually Angular 2 is a web platform and it packs some other libraries, like you get TypeScript, but it's straightforward. It's just JavaScript. You get Zone.js, but you don't meet Zone.js until you dig deep in Angular. RxJS is there, and is probably the trickiest part of it. So uh, Angular is now, let's say, 1 year old, but the development started a little more than 3 years ago, and it's already one of the most dominant web frameworks, right? So the other one is maybe React, we could say, if we stay on the JavaScript ecosystem. And the interesting thing is, however, Angular 2 and above 2 is the younger version, but actually it is the more traditional way of building applications, because you have your component code, you have your templates in HTML, you have your CSS file. However, React is shifting towards functional programming, and they successfully merged HTML into their JavaScript files. And they are experimenting with CSS in JS. So there is a paradigm shift going on, and RxJS in Angular allows you to do something like that. So do an application in a functional way and leverage its advantages. So let's say, what is functional programming? Functional programming is a flavor of programming, a style. Of course, there are dedicated languages to functional programming, like Erlang, PureScript, just to name a few. But in JavaScript, it's an option. Well, functional programming is basically relying on pure functions and putting a lot of functions together to build something working. And pure functions are key to this. Pure functions are avoiding share state, mutating data, mutating global data, and avoiding side effects. This means that every function's output is determined by their inputs. It makes it easier to test, it makes it easier to reason about, and if you are good at naming things, then it may become more readable. So, in addition, RxJS is called reactive functional programming because when developing a UI, I'm pretty sure you're familiar that you are basically dealing a lot of asynchronous stuff, user interactions, the user clicking that button, I/O. Let's say you are working on an Electron app, so you are writing some files and reading HTTP requests, all these asynchronous stuff, and they are challenging, they are hard to know, hard to handle, but there are some help going on, because JavaScript will have async await, which is a language feature, and it simplifies dealing with a lot of promises, and we already have that because we work in TypeScript in Angular, right? So, but what about the more complex use cases when you have really a lot of asynchronous streams, user clicking that button still, and you have like a video stream? I mean, Netflix uses React, Redux, of course, and RxJS to stream video. Actually, RxJS is coming to JavaScript, maybe. There is a proposal for that, but it's a very early stage, so there may be some time before it will be native. So, RxJS is basically called reactive extensions, and it is available in many languages: Java, C#, C++, JavaScript, of course. So it basically implements an observable pattern. That's no-brainer. You can subscribe to it, you can get an event. This is just similar to promises, but you can get more than one value. Actually, if you look at the diagrams, it shows some of two operators that you can do with it, and it is the most one of the biggest advantages in RxJS, that you can have lots of operators that alter your stream's behavior. You can create observables from basically anything: array, promise, array promises, promise arrays, and DOM events, basically anything. And you have operators that transform those. You have observables to filter those, and really do some complex behaviors in an asynchronous manner, very, very simplified way. So, yeah, and the other advantage is that you can build new operators relying on already existing ones, so you can build more and more complex one, and the testing. So you can easily test asynchronous code, complex asynchronous code, not just one callback, but a lot of them. So I will show you. So, and how do we use this in Angular? Well, the HTTP service returns observable. However, it could return a promise, a simple promise, but it returns as observable. Angular event emitters are basically observables. If you want to show an observable, you can bind to it in your templates with an async pipe. So basically, if a user does something, if you send an API request, or if you want to show something, so basically everywhere you can use RxJS in Angular. But it's not mandatory, so you choose how much you rely on RxJS. So let's say we have an Angular component without relying on RxJS. Our application state is in the component's properties, lying there. The behavior is scattered around event handlers, so every button have an event handler function, and it is mutating our application's state in some way. And that's actually not good, and it requires us to split our component to more smaller and more granular parts to be able to cope with that complexity. However, with RxJS, our application state lives in observables and subjects, and you have very much fewer event handlers, because you put your click events and anything that the user does into subjects, and this flows through your RxJS pipeline, so your behavior is described in these pipelines. Well, to show you, we will do some very basic operator just to show how it looks like in the code. So let's say that we want an operator that allows us to stop an observable from emitting values and then resume them. And as you can see in the GIF, it stops, resumes, stops and resumes our basic observable. And what we did is that basically we have the observable that's emitting some data, whatever, don't care. And we have a condition that another observable that emits Boolean values, true, false, whatever. And when it emits a false value, we just switch to a never observable, which is never emits anything. I hope that doesn't surprise you. And when the when observable emits a false value, then it emits a we are switching back to the original observable. So we are using switch map and never operator to basically build a new operator. And let's see how we test that. All right, so we have basically 3 strings and we are done with the test. Actually, this is my favorite part. While we have the 3 streams, the condition stream that emits false and true values, the main stream that emits some data, we want to stop and resume, and our result stream. The strings are called marbles, and you can define every character what it should mean. So right now, F and T letters basically just true and false value, the rest is we don't care. But you could say that, okay, but there is that little function and I could have the universe behind it, but it's just, don't be frightened, it's just, it looks ugly, but it's not that difficult. So we're basically just creating observables from those marble strings, and at the end of it we say that our expected observable when we applied our operator should be that marble string we said. So basically we are testing that when the conditional observable emits a true value, we stop emitting values from the main observable. As easy as that. There is no callbacks. I didn't write any callback, just putting some strings and asserting that it should look like that way. Okay, how it looks like when we build a more complex pipeline. So, let's say we want to have an object that encapsulates some of reusable functionality. So let's say the user enters some search criteria and we send a request. When the response arrives, then we want to show a list of values. The request also contains a next page token, which allows us to paginate our list, so the user can load more data to the list. Also, the user can filter additional items from the list on the client side. Just a couple of features that show that we do some asynchronous stuff. Also, for example, the user can add new items to the list, whatever, just for the example. Okay, I won't show you the whole code because it doesn't make sense, but this is only just to emphasize how it is to work with RxJS. Basically, you are building up streams and building up steps. What should you do when something happens? Like, we have this query, and when we have anything from this query, we want to send a true value to a loading source. Let's say we have this loading source, and when it has a true value, then we show some spinner, a loading bar, whatever, indicating that we are working in the background. Okay, but when we have anything from the response, then we send a false value to the loading source that we are stopped loading the data. And we will probably show the list of data. Okay, when we have the response, we can transform the response to a next page token and send it to its own observable for later use. Also, now is the fun part. The response can be transformed into an item list, and if the user adds a new item to the list, we can merge with it. So we don't really care if the new items coming from a request response or the user is adding them. We just merge them together and handle all the same. And we say that, okay, then let's have our list source that contains the item list, and we take one. We take the last one, and then concatenate it with the new items. Alright, so right now we just put the new items and concatenate it with the old items. Also, when the user enters some search query, we just put an empty array in it. We just switch it, because when the user wants to search, then we should throw out our current items. And of course, we can have some debug operator to show if some data is going through our stream, and at the end, we just subscribe and send to the list observable to our list items. Okay, this is pretty complex, we should say. So we would expect that it's hard to test, but actually it's not much more complex. Like, okay, we don't have 3 strings, we got 8, but they are not so hard. So just, where is that? All right, so we have these marbles. The first one is meaning that every time there is an S character, user sends a search. Every time user clicks on the button that allows him to load more items to the list, then that is the M character in the load more marble. The request marble means that when the request arrives, our list marbles mean that what is emitted on the item list. So basically, I can define what are these characters mean. I say it again because so the E character means that it's an empty list. The I character means some list that the request returns. So this way I can define that what happens and when should be the output, what should be the output observables result are. And going through the test marbles function, it's basically the same. It's only just more than one observables. We just take the marble values where we define that what character should mean what value, and subscribe to our pipe object that we are building, and at the end we just expect our observables to be our output marbles. So this actually makes a lot easier to work with asynchronous data, because there is more and more complex features, but you can tame them. You can build up pipelines, you can extract them, you can make them reusable, you can build up operators to further optimize your code. And I'm suggesting to you to take a look at RX Marbles. If you have ever worked with RX, basically you will know it. But if you don't, it's very good. It has a lot of operators in an interactive diagrams, so it explains well what they do and how. Also, the documentation, of course, and you will find the marble testing description, how to test your pipelines. And also, there is a lot of animated playground, like RxViz is really good. You just write some code and you see immediately how it emits data and works. So that's it for me. Any question? We are all tired. Yeah. So basically buffers. I think there are multiple buffering operators in RxJS built in. But of course it depends what you want actually, but there are buffering operators. Yes. Yes. You can do that. You can do that. Basically, this operator is just skips them when it's paused, and it can be used like when a user clicks on the search, and as long as the response is not arriving from your backend, you don't want to send more responses. So you want to stop the stream and not emit values after. But you can have those that behavior be the buffering operator, and there is some buffer operator, so it's basically there. Anyone else? We are already tired, so thank you for being here, thank you for having me, and good evening.